The power that powers the sun. Harnessing it, the holy grail of clean energy. Nuclear fusion, long a reality on the silver screen.
What are you doing, Doc? I need fuel.
Powering everything from spaceships to time machines. Now, scientists at this lab say fusion is a step closer to the real world. Researchers here used lasers to create conditions similar to the sun, slamming hydrogen atoms together to create a fusion reaction. The breakthrough, according to officials, more energy was released than used in the process. Proof of life for fusion power.
Simply put, this is one of the most impressive scientific feats of the 21st century.
The potential environmental benefits of fusion are obvious. An abundant source of clean energy to help the planet kick its carbon addiction.
It's a game changer because it's dense, a very small area that it requires compared to, let's say, wind farms or PV.
Like wind and solar, fusion as a reliable source of green energy is the goal. But it's an elusive one. Many in the field joke that fusion power is just a decade away and always will be. And some worry that if this breakthrough is what fusion power looks like, it won't solve the climate crisis.
It took the energy needs of a small city to power up the lasers to produce for a fraction of a second a small surplus, about enough energy to boil a jug of water and make a pot of tea. So that's no solution to our energy needs.
Still, this latest discovery could lead to more funding for fusion research, likely the key to making fusion power anything more than science fiction. Aaron Collins, CBC News, Calgary.
This is where we need Bob McDonald, host of CBC Radio's Quirks and Quarks. So, Bob, obviously I get this is an enormous moment, but could you help me out? What exactly just happened?
Well, Adrienne, what they did today is nuclear fusion, which is different from the way we're generating nuclear power today. Today, we take atoms and we split them apart, and that gives you energy, but the parts that are left over are radioactive, and that's a waste problem. Fusion is the opposite. You fuse things together, and when you fuse them together, there's a little piece that's left over here that flies off, and that gives you the energy that you're looking for, and what's left is not radioactive. It's helium. It doesn't heat up the atmosphere. Fill your party balloons with it. So that's the idea. Now, what they did with this experiment was that they hit a little tiny target that's the size of that, and I'm not kidding. They fired 192 lasers at this thing, and they heated it up to 100 million degrees, and for a fraction of a second, it went pop. And what came out of that pop had more energy than the lasers that went into it. That's why everybody's exciting. But in the future, we're going to need a new design just to make electricity.
So this isn't close. Obviously, it's been decades, could be a while. But what do we need to watch for next, briefly?
There are a couple of projects under construction right now. One's called ITER, the other one is called Spark, and they make a donut, a plasma of super hot 150 million degrees gas that burns continuously. And they're expecting to get 10 times the energy out that they put into it, so it will be self-sufficient. They're expecting to get the first plasmas around 2025, and we should see some commercial reactors in the early 2030s. That's the timeline.
All right, the great Bob McDonald, thank you.
Okay, Adrienne.